spin currents are always in parallel. The spin current is always propagated by a charge current in a way. And so the question is now, can we have spin currents that are independent from charge currents? And then the answer is, of course, yes. Otherwise I wouldn't hark so long on this. So most people, when they think of spin currents, they think of something like this. You have a charge current, and it's carried by different numbers of spin up versus spin down electrons. Now, what I'm interested in is so-called pure spin currents. And that you can think of something like this, where you have a spin up and spin down moving in opposite directions. All right? And so what you see easily is, when you have this situation, there's still a net spin current, but there's no net charge current associated with this. Now, why is this interesting? Well, if you look at a basic physics kind of ideas, if you want to understand how spins behave, it's much easier in a pure spin current experiment. Because when you have a pure spin current, it's only spin-dependent physics that matters. If you have a spin-polarized charge current, any spin-dependent effects happen on top of whatever charge current effects, charge transport effects you also have. So if you want to understand whether spins play on how spin orbit coupling, for example, matters for spin transport, or if spins carry any energy with them, or spin interactions in general, it's just much easier to investigate in a situation like this than if you look at the spin polarized charge current. Now, from an applied point of view, as I said early on, maybe you can use pure spin currents to do things with less dissipation. And with the caveat that with what we do so far, we are not quite there yet. But if we manage to do this, we may have less heat in our devices. But also, when we separate the spin from the charge current, we also separate spin from charge noise. And in terms of signal to noise, you may have some benefits. And since there's no charge current with a pure spin current, there's also no magnetic Ørsted field associated with it. And so there's no fields that can feed back on some of the other elements that you may have in your devices. Now, how do you get a pure spin current? Well, the first experiment was actually done by Mark Johnson and Roger Silsby in 1985. So this is remarkable. This is 1 year before giant magnetoresistance was discovered. So these guys were really quite ahead of their time. So what they did is they took a non-magnetic wire. In their case, it was a high purity single crystalline bar of aluminum.